Right, and then the next part of 5.1.2, we're focusing on the problems 33 through 43, where we're going to bring together the two things we learned from the previous lesson, which are how to graph the parent function, that procedure, along with those transformations and actually doing some graphing rather than just matching. Okay, so we have two examples. And you'll see a little bit of each of these four transformations. So these examples are just kind of a touch of it. So let's start with example A. So graphing, I'm adding that step 4 of applying the transformations. Really, I'm going to incorporate that as I go. So my parent function for A has a 3 to the x. My parent is, let's see, a transform, so it's y equals 3 to the x, and it's shifted horizontally because that plus 2 is with the x, so that's this form right here. So we're shifting it left by 2 units. So shift left 2 units. So that means that step 1, when I would plot it, my point right there at 0, 1, I know that, when my exponent is 0, my y will be 1. But here, I'm actually going to shift that left 2 units. So that point becomes 0, negative 1. Sorry, that's not right. I went down 2 units. Left would be negative 2. So that point actually moves over here. And then in step 2, actually I'm going to keep my blue. Step 2, we, in our parent function, actually I'll change to purple. My parent function, remember this, my points are b and 1 over b. So my parent function is 3 to the power of x. So that b is 3, and 1 over b is 1/3. But I'm going to shift that 2 units to the left. So I actually get my graph for this function is going to be shifting left 2 units. So I get negative 1, 3. So I have a point at negative 1, 3, and negative 3, 1/3. So right here. And then nothing happens to my horizontal asymptote because it's just a horizontal shift, so I'll still have that same horizontal asymptote at the x-axis. And my graph looks like something like that. And you may notice that the parent function was, something like this, which we just shifted left 2 units. Okay, so I'm actually going to erase that black, the parent function, because I don't want that on my graph. I just want that final graph of that blue graph that's already been shifted. And then I was asked in the directions to state the y-intercept, the additional points, the domain, the range, the horizontal asymptotes. We already did a little bit of that. Whoops, let's do a little yellow here. We did our y-intercept. We shifted our y-intercept, didn't we? Well, we did our 2 additional points anyway. So let's find out the y-intercept. The y-intercept is what is y when x is 0? So when I plug in a 0 for x into this parent, not to the parent function, to the function that I'm graphing. So if I plug in a 0 then I get 3 to the power of 2. 0 plus 2 is 2. So that gives me the y-intercept will be 3 squared, or 9. And then the two additional points I have right here, those are my ones and negative ones that have been shifted. So I have a negative 1, 3, and negative 3, 1/3. My domain hasn't changed from my parent function, so that one goes from a negative infinity to infinity. My range also has not changed. That starts at 0 and goes up forever. And my horizontal asymptote didn't change because I just did a horizontal shift. So my horizontal asymptote is still y equals 0. So that's my first example. All right, let's do example B now. So again, our parent function is e to the x, and that one is shifted right by 1 unit. So my intercept, the parent function has the intercept of 0, 1. When I plug in 0, e to the 0 is 1 because anything to the power of 0 is 1. So that's going to shift to the right by 1 unit, so that becomes 1, 1. So now that y-intercept has shifted over to here. And my other 2 points, so I would have, on the parent function, I have 1b and 1 over b. Which in this case is e. And e, I'm going to write this. Let's see, where should I write this? This is an important, e is approximately equal. E is a number. It's an irrational number, so we call it e. But e is equal to 2.71828. It goes on forever, but that's an approximation of it. So when I say 1e, it's really 2.71828 and so on. So I can estimate that. But again, we're shifting right. So we're going to shift right by 1 unit. So really, my point's going to be 1e plus 1, which is approximately 3.71828. So I go to 1, and then 1, 2, 3, almost 4, so right about there. Whoops, that's not right, is it? Sorry, we shifted right 1. I did the wrong thing. Let me undo that. Sorry, we're shifting right, not up. So we keep the e, but shifting right, now that becomes a 2. And we still have e. So at 2, I have 2.7, almost 3, right about there. And the 1 over e, if I take the reciprocal of that, if I get my calculator and do 1 divided by e, then I get, let's see, what do I get? I get approximately 0.36788. So about 1/3. So I'll do 1. Oh, I'm sorry, that shouldn't be 2 anymore. So shifting right 1 unit from -1 brings me to 0. And 1 over e is about 0.36788. So I'm going to 0. And then that's right about there. And then my smooth curve going through those, it looks something like that. I don't really love the asymptote there because it's supposed to get closer and closer to 0, so I'm going to redo that. There we go. All right, so there's my graph that's been shifted right 1 unit, so that's e to the x shifted right 1 unit. My y-intercept, actually I found that right here. That was 1 over e. So I'll say when x is 0, y is 1 over e. And the 2 points I found, well, let's see. We have the y-intercept that was shifted, that's 1, 1, and the other one is 2e. And then my domain, my range, my horizontal asymptote, none of those have actually changed because I just did a horizontal shift. So those will stay the same. It would change though if I do a vertical shift, which we'll see in a minute. All right, let's do 2 more examples. So let's move on to C. We have a vertical shift. So our parent function is y equal to e to the x, and we're going to shift. That's a vertical. A vertical shift down. So that's a shift that down by 2. So I can graph e to the x, which I kind of remember from above looked something like going through 2.7. Kind of looked like this, right? And we're going to shift that down by 2 units, 1, 2. So that's kind of the quick sketch way to do that. I'm going to do it more officially here by finding some points here. So what happens to that 0, 1 point? That got shifted down 2. So that became, whoops, that became negative 1, 1. And then our step 2 in the parent function, e is our base. So if we have a point at 1e and negative 1, 1 over e. But we're going to shift that down 2. So we end up getting, so for step 1, that one's right there now. And in step 2, we get 1e moves down to negative 1e. And remember, our e is about 2.71828. And our 1 over e was about 0.36788. So 2.718 shifting down 2 is now going to be at about I should have done e minus 2. So that's approximately 0.71828. So you can see that one's crossing right there now instead of at the 2.7. And then 1 over e, that used to cross at the 0.36788, but that went down 2. So we do 1 over e minus 2. So that crosses right here now. So that gives us our curve. And then our y-intercept, that one we got oopsie, I did that. I wrote that y-intercept wrong, didn't I? Sorry, that y-intercept should have been 0, negative 1. There we go. I did it right graphically, but wrong in the point. So that y-intercept is 0, negative 1. That one shifted down 2 points, 2 units. And then the 2 additional points we got are negative 1, and then e minus 2, and sorry, that's a positive 1. That's a positive 1. And then negative 1, 1 over e minus 2. And our domain is still the same because left to right we still go from negative infinity to infinity. So vertical or horizontal shift, that's not going to change. But the range does, because my horizontal asymptote also shifts down 2 units. So now that I have a horizontal asymptote at y equal to negative 2, that means my range will start at negative 2 and go up to infinity. So a little bit different from the horizontal shift in the range changing and the horizontal asymptote changing. All right, and then the last one for D, we have a reflection. So I did a reflection over an x-axis because our negative is with the x. So wait, sorry, over the y-axis because it's with the x, which means all the x's from positive. If it was like this, everything, all the positive points are going to become negative points. So it flips over the y-axis. So I know that the parent function y equal to 3x, I know what that looks like. And I'm going to reflect it over the y-axis. I know that y equals 3x means there's a point here, and there's a point at 1, 3, and there's a point at negative 1, 1/3. Those are my 3 key points. So that's my parent function, so I want to reflect that over. I should do that one in a different color. I'll do that one in like a gray. So the function that I want is that transformed, so all the x's become negative and all the y's, whoops, and all the negative x's become positive. I'm still going to go through that 1 point, so it should be something like this now. All right, I'm still going to check my step 1, 2, and 3. So my y-intercept is still going to be a y-intercept of 0, 1. That doesn't change because when I plug in a 0, a negative 0 or positive 0, those are the same thing. Those are both 0. So 3 to a negative 0 is still 1. But my 1 and negative 1 have swapped, right? So originally 1 went to 3, and now 1 goes to negative 3. Or 1/3, sorry. 1 goes to 1/3. Whoops, that's my parent function. In my parent function, it was b and 1 over b. But in this function, it's going to be the reciprocal of that because it's negative x. So I go to so 1 maps to 1/3, and negative 1, when I plug in a negative 1 there, I get 3 to the 1, which is 3. So that's where I got this point and this point. And then step 3 is drawing in that smooth curve. And I'll go ahead and erase that. Well, I guess I'll leave that gray function there. I kind of like seeing that. Okay, so my y-intercept has not changed. It flipped over the y-axis, but that doesn't change the y-intercept. My 2 points have changed. The y swapped. And then my domain is my domain and my range won't change. There's no change vertically. My infinities are looking crazy. Okay, still crazy. And then my horizontal acetone also still has not changed. And there we go. So there's 4 different types of transformations on a couple different examples. So I popped in the parent function in gray on each of those 4 graphs so you can see that transformation. A was shifted left 2 units, so you can see the gray going left 2 units. B was shifted right 1 unit, so you can see that. And then C shifted down 2, and then D we did from the gray line, so that's reflected over the y-axis.